sometimes like, let's say we're given two arbitrary points in space. So we have like the XY plane, and we have like one point here somewhere, another point here, maybe. Maybe sometimes we're like curious and we want to know, well, like what is the distance between the 2 points? Like, what is this red length here? Like, what is the length of that red line? So let's say that we know that the coordinates of the 2 points are x1, y1, and x2, y2. So let's say we knew the coordinates of the 2 points. Now, what if we wanted to find what is the distance? What is this length of this red line here? And to find the length of this red line, we can actually use the Pythagorean theorem by, like, what we can do is we can do something similar to slope. Remember in slope, we kind of, we kind of did this thing where we kind of built this triangle. We kind of had this like red length here, and we kind of had this blue length here. We can kind of do the similar thing and build kind of like a triangle in order to find the distance. So down here, what we can do is we can find the distance between the y coordinates and find the distance between the x coordinates. And this is going to be a right angle here because, like, the x and y axes are always like perpendicular to each other. So this blue length here, we know that the first point here has a coordinate of y1, and the second point has a coordinate of y2. So the length of the blue distance is just going to be the difference between the y coordinates. So it's just going to be y1 minus y2. That's going to be the distance, the difference in the y coordinates. Now for the x coordinates, we know that the first point has an x coordinate of x1, and the second point has an x coordinate of x2. So this green distance, the difference between the x coordinates, is going to represent the distance. So we're going to have x1 minus x2 is like this green length. So like now we can kind of apply the Pythagorean theorem. If we let d be the length of this red segment, then remember that like last week we talked about the Pythagorean theorem, that like the sum of the squares of the legs must equal the square of the hypotenuse. So that tells us that x1 minus x2 squared plus y1 minus y2 squared. And this has to equal the distance between the 2 points, d squared. Because we kind of built this right triangle here with a red side length, a blue side length, and a green side length. And we can kind of build this Pythagorean theorem equation here. And if we wanted to solve for the red length, we can just take the square root of both sides, and we get that d is going to equal the square roots of x1 minus x2 squared plus y1 minus y2 squared. And this is like the distance formula, which is like very important in coordinate geometry. So how you would remember this is you would just take the difference between the x coordinates, square it, then find the difference between the y coordinates and square it, then add those two results together and take the square root, and that would give you the distance. Let's talk about like 2 more example problems on how we can use like the distance formula then. So let's take a look at example 3.1. Like find the distance between the points 2, 3 and 10, 9. So let's say we want to know the distance between these 2 points. Then like what we would do is we would just use the distance formula, right? We would just take the square root of x1 minus x2 squared. So 2 minus 10 squared plus, and then we take the difference in the y coordinates, y1 minus y2 squared. So 3 minus 9 squared. So what we would have is, this is equal to 2 minus 10 is negative 8, square that, you get 64. 3 minus 9 is negative 6, square that, you get 36. So 64 plus 36 is 100. So you take the square root of 100, and you would get 10 as the distance. So yeah, I don't think that was, hopefully not too difficult. Like that was just kind of plugging in the numbers and just using the formula directly. And let's take a look at one more example, example 3.2 really quickly. Example 3.2 says, find the value of x such that the distance from the point x0 is the same to the points 1, 2, and 10, 7. So basically we want to find what is the value of x so that the distance between these 2 points and the distance between these 2 points are the same. So this is a slightly more challenging problem, but like it's still an application of the distance formula. What you would do is you would first find the distance of these 2 points, which would be the square root, and you take the difference in the x coordinates, so x minus 1 squared, and take the difference in the y coordinates, 0 minus 2 squared. And now you find the distance between these 2 points. That would be the square root of x minus 10 squared plus 0 minus 7 squared. And we know from the problem condition, these two must be equal. So if you square both sides, then like that removes the square root. So you would have x minus 1 squared. 0 minus 2 is negative 2 squared, that you get 4. This has to equal x minus 10 squared. And then negative 7 squared is 49. So if you were to expand out the left side, you would get x squared minus 2x plus 5 if you were to simplify everything. And on the right side, you would get x squared minus 20x plus 149 if you were to expand everything. So conveniently, the x squareds cancel out. And if you rearrange, add 20x to both sides and subtract 5 on both sides, so you get 18x is 144. And if you were to divide by 18 on both sides, you know, x is 144 over 18. And if you do the division, you get x is 8. And yeah, that would be your answer.